All right, so we're recording. So thanks everyone for listening if you are. I'm Josh Lambert, product manager here at GitLab. Ben, want to introduce yourself?
Hi, I'm Ben. I'm the backend engineer on the Monitor team.
Andrew?
Hi, I'm Andrew, and I'm in the infrastructure group, and so I'm very involved in debugging infrastructure issues that we see on gitlab.com. But it's worth noting that that's not actually cloud native. It's still Ruby running on VMs, but many of the challenges are still the same.
Andrew's doing a lot of awesome work with GitLab and helping to improve some of this, which I'm sure we'll get into here shortly. Stan, you want to introduce yourself quickly as well?
Sure. My name is Stan Hu, engineering fellow. Like Andrew, I also spent a lot of time debugging things on GitLab.com.
And thanks for joining Stan by the phone there. Awesome. Ben, you want to kick things off for us here?
Yeah, sure. So I kind of wanted to start with like how did you debug? How did I start debugging applications? And so like my first debugging was when I was in school, and it was just like, oh, I've got a C binary that I'm writing, or whatever program I'm writing, and I've got like local debugger tools and like GDB and classic local debugging tools, and like maybe some print statements and a bunch of other things. And like that was my developer experience early on, was like, okay, I'm sitting on my computer with a terminal in front of me, and it's just me and my application. Cute little person sitting in the corner doing their job, or doing their schoolwork. And then from there, I became a system administrator, systems engineer, and I was deploying my programs or other programs to other computers that were not in front of me. So my tool then was, well, I can SSH into the machine, to the remote machine, and I can run the exact same debugging tools. I can run top, I can run debuggers, I can look at the logs, and so now I've got a log output, and I might have like a syslog file that I can look at, and I've got top and maybe some other like network tracing tools that I can run to like look at how this one computer interacts with another computer, and they're remote on the network. And that got, that was the way to do things for a very long time. And then we started getting to, okay, well, now I've got not one, but not 10, but hundreds or maybe more, servers running the same code. And now I've got a really big problem, is I'm not connected to one server running one binary. I'm connected to 10 servers or 100 servers running the same binary, and I need to talk to them all. And this started me on the path to like more what we call cloud native thinking now. And for me it was just cluster computing. And so we developed, we started using monitoring tools like Nagios. And these monitoring tools would like kind of check in on the application, but it really wasn't debugging. And it was the same thing with when I started doing larger networks. We had SNMP, and then I worked for a big company where we had our own proprietary monitoring that would do all the data gathering, and then we could do some sort of debugging because we now had internal instrumentation in the code. And that was eye-opening for me as a developer. It was like, oh, well, instead of having to look at a log file, I can just aggregate all this metric data and look at it in aggregate. And this was extremely powerful, because then I could tell exactly like how many times an error happened in my code, instead of having to look at a log line or have a log file. I could just look at the metrics for that application, and that was one way to do the debugging. But of course, we had some of these, and so this was when I worked at Google, and we had these tools. But the other thing that we started to do at Google is we started to, for a variety of reasons. Number one, it was hard to aggregate single process debugging. So they started to develop tools that would allow you to do inspections into the runtime of an application over the network. And since Google started out as they were a web company. Every Google process had a web server built in, so I could stop SSHing into machines in production to debug things. I could now just curl an endpoint or just hit it with my browser, and I could just browse every application's HTTP endpoint, which had a debug page on it. And so I could get the metrics from the program, I could get a thread table, I could get a stack trace, I could get all of that over an HTTP endpoint. And this was something for me was completely awesome. But I haven't seen anybody, I did this at Google for years, but when I left Google, I just didn't see anybody doing that, and I was like, that's weird. Why is nobody using like a debug endpoint to inspect their code? And this has started to now form as like, okay, well, we continue to debug applications by SSHing into machines. I'm doing that today, and I'm still having to SSH into machines to debug the applications because I can't get to the HTTP port. And like we really need to stop doing this, because getting to the HTTP port allows me to debug a single or an aggregate really easily. For example, the Golang system has an entire system called pprof, and you can get stack dumps and traces and memory allocation information and all these things that you need to debug a Go program without having to ever log into the machine. And it also means that if you had the tools, you could actually just have a tool that would go and say, give me a stack dump and find out how many Go routines and what Go routines are running on 100 binaries simultaneously, and aggregate that and return that to me. And I'm not familiar with the tools for this for Golang, but because I just haven't seen it, I'm hoping that we're going to get to the point where this is more possible. And maybe I'll hand off to Andrew and like tell me a little bit about how you got into like debugging things in production.
Sure. So, I just want to say that Gitly has got pprof in it, and we share the same listener for Prometheus. So if you go to /metrics, it'll give you your Prometheus metrics, and if you go to /debug on that endpoint, it'll give you your pprof, and we have some run books. But exactly as you say, that is sort of debugging an individual server. We have nothing that can kind of go out and profile in parallel all of the, I think there's 30-something Gitly servers in production at the moment. But also I find that's quite sort of in-depth debugging. Like generally, like I find starting off with your metrics is much, and aggregating at a Prometheus level and looking at what's happening to your Go routines in the example that you used is a great place to start. And then sort of as a second step, going and looking through your Kibana log or your elk logs or your structured logging, digging further in there. And then really once you've got some sort of idea as to what the problem could be, that's when I find the pprof interface in particular to be super useful. And there's also operating system level tools that can be fantastically helpful. Today, we've been experiencing a problem with the NFS endpoint, NFS server that's burning up, and we don't seem to understand why, and we don't have the correct level of logging to figure it out. And so we've been using BPF filters to basically introspect that server and figure out what files are being written on that server and why they're taking such a long time to write. And so, down at the operating system level, you have a whole bunch of tools there as well. Obviously, strace and all of that, but BPF and perf are two others. And the one tool that we don't quite have yet at GitLab is obviously distributed tracing. But we do actually have the instrumentation in the code, and really the next step is to set up a distributed tracing cluster that we can collect the traces at. I think we've lost Dan. and so that should hopefully come pretty soon, just as soon as we find some time to get that in. But I can imagine that that's going to also be tremendously helpful in helping us diagnose things. So, but I think the way that I tend to go is, from the metrics. Everything starts with Prometheus, and then move from sort of low ordinal metrics, into your distributed traces or into your logs, and then from there into your pprof and your profiling and your operating system tools to kind of look at things at a lower level.
Yeah.
But certainly, I've never done those sort of last level in aggregate, and I think there's something really interesting there that you could do. But I've never seen that done, and it would be amazing to investigate.
Yeah. Well, and one of the more interesting things is, if you start to, think about when we move from, we're using when we talk about cloud native, we're talking about easily deployable components, and that could be VMs running in, and that could be containers. And so I don't consider them. I don't consider doing things in a VM infrastructure not cloud native, because there are for example, we run our CI fleet with an entirely auto-scaling, auto-provisioned system, so that we're not managing individual machines in production. We're just launching and throwing away VMs constantly, and there are GitLab customers that are using auto-scaling groups to deploy their GitLab instance. And this is totally a normal, and what I consider like cloud native. It's not as fancy as a container infrastructure, but they should be no different. And when you get to one of these auto-scaling groups, your machine might not be up long enough for you to log in and debug it, or you might have the machine up, it had a problem, and then you need to come back to it later, but it's been recycled by the time you get to it. And that's another reason for having these distributed tracing and logs and metrics, is that you need these external observability tools in order to collect the data and store that for later use, that is outside of the compute resource side of things. And there's another thing I was thinking about the other day. Was somebody's like, I was commenting on, oh well, you have like 4 different monitoring systems, and you should maybe we had the same problem at SoundCloud, and we wanted to consolidate down, because we had Nagios Isinga. Well, we had Isinga, but it was basically running in Nagios mode. We had Graphite, we had New Relic, we had, and then we were working on Prometheus, and we had a goal of getting that down to just Prometheus. And then somebody pointed out, well, but that's not going to solve all your problems. Like, well, no, it was actually, I spoke to, I didn't include enough information, is we also had a logging stack. We had our own logging stack, and that that is a separate thing. Like you were saying, is you have the metrics, and I thought about it a bit, like, well, so metrics and this low cardinality data covers 90% of your debugging needs, and like it gets you 90% of the way. And then the logs, to me, like logs is the next step. Like logs gives you the next 9%, and then the pprof and the trace tools and the open tracing and Jaeger, that gets you the last 1%. And it's not about how long you spend using those tools. It's about the problem space. Is the metrics gets you solves 90% of the problems, but that may only be some part of your time. It's the really, really deep, weird problems that it's the corner case problems. Those are the 1% problems that you're trying to solve with those super low level debugging tools. And I really want to get to the point where from a cloud native perspective, I don't need to log into, and I don't need SSH anymore to get into a machine to run those tools, or to get the data I need out of those tools. And from my knowledge of the way things are at Google these days, they've gotten to the point where a Google engineer can work from a Chromebook with a browser only and no SSH. Is 95% of the engineers at Google never SSH to machines in production anymore. They do everything through metrics tools, through logging tools, through tracing tools, and it's all done in an aggregated way on top of their clusters. And I really want to see the open source community get there as well.
Probably worth noting that SSH sort of stops working as you noted, like the machines come up and go down so fast, but also your containers might not have a shell on them. And then what do? Do you SSH into like the node host, at which point you have pretty low level access to the entire cluster and try and do debugging there? Like that doesn't really
security
work.
People are, and from when I put on, I'm an S3 at heart. I'm a hacker at heart. And when I put on my security hat, I'm like, no, I want to get rid of that, because I want to use we're building network isolation and application isolation into the VM infrastructure and the container infrastructure in order to protect our user data. And as soon as I allow SSH, and I've just completely blown away all that security possibility. And so by having in-cluster applications that provide my debugging, I can deal with the threat side and deal with the security side in band without bypassing it with this, with SSH. And like you said, like if you look at some of the containers that the monitoring, like the Prometheus containers, we run those containers have nothing in them. We currently put BusyBox in it just for for debugging convenience, but in reality, the only thing I want in that container is the Go binary or the JVM and the jar files that I need to run. And I don't want my containers to have all this extraneous crap in it, because that's more stuff I need to manage. And when you start talking about container infrastructure, we want the containers to be as thin as possible for testability, for security, for compliance, and just for efficiency. And once we have that, there's no tools in the container. So there's a big long open issue on the Kubernetes side that says we want to be able to attach debugging containers into our containers. And I'm like, no, that's the wrong way to do it. We really need to get out of the attaching debugging tools in process. We want to attach debugging tools over the network. And this is super easy with Go. It's reasonably easy with JMX, but we need to figure out some way to also get the same stuff out of Ruby. Is a lot of people do Ruby debugging with a Ruby console, and how can we do that over the network and do it over HTTP instead of doing it with a local process access? I'm Ruby ignorant, so I'm just going to leave that for other people to answer.
Okay, so that's a good example. Ruby has the biggest shortcomings right now. I guess the question is, how do you want to take this conversation? Because yesterday is a good example. We had some issue with one of the endpoints, and it was funny because Andrew and I kind of approached it differently. Andrew looked at the logs and saw high rates of a particular controller, and that really gave us definitive metrics on there's something wrong with this controller, right? And I actually SSH in the machine because we couldn't find the error in Sentry. So I went to the machine and started looking for unusual things, and I found the exact same thing he did around the same time. And, we approached it two different ways. His probably more rigorous, but mine was, I just tried to get something fast. But did the Ruby console help here? Not in this case. I mean, I think this one had to do with just raising a high level, I guess, high number of exceptions. And I guess we just didn't, even though we have Sentry, we don't have a great way of saying this is clearly an error that's happening way too much. And we can pinpoint the controller, but we have to actually dig into the logs to figure out what exactly what's going on there.
Yeah.
So to your console question, that's a different question. I mean, we can certainly talk about, we can get access to the database or have a console or something that you want to attach, but I don't know. There's two different approaches we can go here.
Yeah, no, and that's the thing is like, even, we need to make it easier for real-time access to the logs without having to SSH in the machine. It's unfortunate that it required logging into the machine just to see that log information.
It was two approaches, but technically, we didn't need to do that because we both sort of came to the same conclusion, like through different approaches, but we do have pretty good like real-time log information. Stuff arrives in Kibana sort of 30 seconds, 10, 20 seconds after we emit it from our application. So it does get in there. Like I do find, I wish we could sort of move a little bit faster with actually building queries in Kibana that kind of get us to the right answer. And I wish we could democratize that a little bit more and sort of give everyone the ability to kind of fold things in the right way. I think Kibana is sort of sometimes a little bit more difficult than it needs to be with that sort of stuff. But the information is there, and we do have it fairly real time.
So we have the information. We just need better tools to use it. And that's
right. We have too much data almost, right? It's the same problem. Too much data. How do you get the signal out of the data?
I mean, like pretty much anything. If you're trying to look at like log streams on any sort of cloud native application, it's really hard to spot the trend. If you have 100,000 lines of logs coming in a minute into a particular log, just say you get 100 lines on the page, that's whatever 1,000th of what you've seen in the last minute. And so trying to find that trend in the data is really hard. And so having the ability to aggregate around high cardinality values. Unfortunately, Stan and I both spend quite a lot of our time on abuse issues. And with abuse issues, it's always high cardinality because it's always a username or an IP address or a project that is the thing you're aggregating on. And sadly, we can't aggregate on those in a traditional metric system. And so, you have to look at kind of rolling that data up in something like Kibana and then saying, hey, look at the project is just, taking all the CPU, what's going on there. But obviously we always start off with the metrics and the alerts from Alert Manager that are saying, this machine is burning up, this service is not fast enough at the moment, or whatever it is.
And then you use your next level of tool.
Yeah. I think one of the things that I've kind of been tracking and from afar is with the distributed tracing. What seems to be really interesting is how a lot of the traces now are moving away from somebody, in the same way that we're moving away from having logging where you actually just go and look at the logs because it's just too much data. It seems like a lot of the trend in distributed tracing at the moment is also trend analysis. So basically secondary systems that are ingesting the traces and spotting, this all the traces that are sort of around this system seem to be slowing down, and they, what's going on there. And so actually it's kind of like a meta-analysis of the traces, and I think Expedia are doing some really interesting stuff around that. I haven't played with any of it, but I've been reading about it and it seems really interesting.
Yeah.
I've heard similar commentary that basically tracing is good for two things. One of them is like diagnosing a particular trace, like this, like we know this one is bad, or we want to look at this one, and then the other one is what you've noted is that building an aggregate or is a statistical model of like what normal traces look like, and then detecting drift from those, whether it's abuse or something going on in the application or something else like that that could potentially spot someone out, like some unusual behavior for the norm. So that's really interesting. I'm not aware of any tools that are.
Yeah, and then getting to the right person too, right? Like it's one thing to flag a trend or something, but then you have to direct it to the right people or the persons who could handle it. And that's also part of the problem, I think.
Yeah. I really like the way Sentry's going with that, Stan, where we haven't used it very much here, but it has some tools that can allow you to set up rules for auto-assigning an exception in Sentry to a particular team. And you can sort of look through the stack trace and you can say, if app models project is in the stack trace, then assign it to this team. And I think like it, obviously it's a hard problem, but I think it's a good step in that direction.
Yeah, that's one thing that we would like to do with our integration with Sentry, is to start like then labeling things or assigning, like at mentioning people and like within GitLab, or assigning issues to them and things like that to help close the loop there.
If we could use like git blame or annotate and kind of apply that on top of the stack trace, that would be amazing.
It would be. That's kind of what I do too. I kind of go back to the stack trace and unwind it to see if there's anything changed in the last month, and then I'll just ask that person directly and say, hey, this changed, maybe that's something to do with this. So I think that's a great idea.
Yeah. And sometimes it wasn't a change that they did, but they're also aware of like a downstream change. And, sometimes they're like, hey, this is the person you need to speak to. But, at least it's a way in. Like what I find I'm often doing is like literally 5 minutes before this call, I just put a message into Pash backend, which is where our backend developers tend to live. And I was like, I saw this strange bug. Does anyone know what this is? But, it would be great if I could sort of get a better idea of that, because we're kind of getting to way past Dunbar's number in terms of developers, and knowing who's working on what is becoming difficult.
Well, we're coming up on 30 minutes of the recording.
I had one other quick question, if you have a couple more minutes, which is, how do we think these tools could help solve some of like the development type solution, where if you're a developer trying to build some of these services or understand how they're behaving in a cloud native way, like how does that happen? I've heard stories of people trying to do like set up Minikube with like local volume host amounts, and that way you can sort of do some real-time development work and sort of have it reading off files off of your disk. But that doesn't seem to be a great.
That's kind of getting into that whole debugging containers that Ben was talking about. I think it just needs to be easier to get these logs off those systems right now. Right now you have to install, FluentD and then the Kibana and Elasticsearch and all these things just to have your logs come off your machine. It really needs to be kind of native to the container, right? Just point it to this log aggregator or something. I think that's what Google's trying to do with Stackdriver. But it really needs to be that simple, right? The logs are just part of container that you can access without having to go into the machine.
And I mean, one of the things that we have done that with, which might seem like an overkill at first, was with the distributed tracing. We've actually got that in the GitLab development kit now. And so, people are like, well, it's not a cluster, it's just your machine. But actually, I don't know how many processes there are in GDK now, but it's at least 8 or 9. And I think developers sometimes struggle to understand how, a request even moves through their simple GDK on their computer. And so one of the things we've got is, if you open the performance bar on any page, you can click a link and it will take you to the distributed trace for that page, and that's built in. And I hope people are finding value from that.
Yeah, no, that's really cool. I just brought it up because it seems like some of these tools could also help sort of the development use case without having to build development containers or ship things you might want to ship in production, which then gets away from sort of having the same images being used across the whole stack and things like that. But anyways. Awesome. Okay. Any other last thoughts, or if not, we can wrap up. And thanks everyone for the time. Really appreciate it and the great discussion. I think we have a couple maybe issues to open after this, which is great. But yeah. But anyways, thanks everyone for the time. Yeah, of course.
Thanks.
All right. Thanks everyone.
Bye guys.
Bye.
Bye.